All right, so we can start with the next one, which happens to be mine, and I'm from Iterators. We are Warsaw-based Scala company, Scala consulting company, as you all probably know, and that's me. I've been here before, so probably there is no need for any long introductions. And I'm going to be talking about that's the title, Crushing Boilerplate with Scala Macros. The title is a bit misleading because there won't be much about macros as API or a way of programming. Maybe more about crushing boilerplate as we define it. And basically it's about an experiment, I would say, that we conducted once in our company, and about results of this experiment. By the way, conundrum, do you know the word conundrum? No, this is the meaning of this word is very simple. It means problem. Well, to be honest, it means great problem. But if you put a great problem on your slides, then it seems a bit whiny and pretensional, I would say. So conundrum gives you this bit of style that we all need, and it's just a better word, but means exactly the same thing. So the conundrum here is that our developers, meaning people at Iterators, were losing time due to some kind of a mindless boilerplate that they were forced to write. Well, everyone is, but for a while we're thinking about where this time is spent. Well, time is just one metric, I would say. But it's very important, of course. You don't want to lose time of your developers, but there is some kind of a burnout involved in writing mindless recurring boilerplate. That is also very important. You don't want people to write this kind of a dual code. No one wants to write it. So we're thinking about how to eliminate this for greater good. And the question that had emerged from this search is what's in Scala that causes this boilerplate? Because we all want to write in a concise, very elegant language, and expressive for some definition of expressiveness. And we hope that in this kind of languages, expressive, concise, and so on, we will be able to express ourselves without repeating ourselves. We'll be able to hit this sweet spot where we are able to write code without, with DRI in mind, to not repeat yourself. But it turns out that, well, no language is perfect. Scala isn't as well, but it turns out that there are some things in Scala, and that's the question that had emerged from the search, that caused the boilerplate to occur. And, well, it's probably no surprise that there are some things in Scala that cause boilerplate to occur, as I said, but maybe it will be a bit surprising what it is. I mean, what we found that Scala lacks that makes it susceptible to boilerplate code. So how did we approach this? First, you need to go through your code bases. Basically, that's obvious, right? Because you need to identify the code that's causing so much harm. And, as all probably companies, we've been writing or maintaining a lot of varied code bases, so we had some kind of a data to work upon. And then you try to identify those patterns. They are not very hard to be identified, right? Because everyone sees those long lines of void, I would say. And then we decided that, well, of course, the patterns in your code base are very well connected to what you actually write. So different companies, different people will have different boilerplate, if that's the right term, in their code bases. But we decided to push as much of this into some kind of a common library because, well, still, it might be useful to other people, not only for us. OK, so first thing, when you write a library, is, and this is a very important thing, is to find a name for it. It's like, forming a band or something. You need a big catchy name, right? Like Rolling Stones or, I don't know, Metallica. So yeah, we searched for a name extensively, and the best we came up with is Kebs. It's a very good name in Polish. Maybe a bit lost in translation in English, but still, I guess everyone here is familiar with Kebs is. So let's go for a Kebs. Let's go with Kebs. By the way, this beautiful logo that expresses the meaning of the name, its essence, designed by Kinga Skarżyńska here. I think it's kind of a work of art. It almost looks like something to eat, right? And we published this library on GitHub. We're still maintaining it. We hope that you find it useful and download it, try it on, or whatnot. But I think that most important thing is that we are looking for, because as I said, what we're doing there is we are trying to eliminate our boilerplate that we found in our code bases. What we would like it to be is to be very generic, kind of a one-stop solution for boilerplate. So if you have any ideas about boilerplate that you want to eliminate and you can't eliminate because of some Scala flaws or I don't know, it's just not possible, but it can be eliminated with some kind of a dirty hacks, then please chime in and send us a pull request or just raise an issue or whatnot. We'll try to solve it or work with you to eliminate, to scratch your itch. So that's Kebs, basically. Our sources of boilerplate. First ones, maybe not the biggest one, but still very, I would say considerably big one, is Slick. So, maybe not Slick itself, but things that happen to you when you use Slick. So basically, I don't know if you write in this style, but more often than not, you want to wrap single values like, ints or strings or whatnot into, to be just kind of a more type safe into wrappers. Essentially, one element case classes for increased type safety. So, for example, you want to create a type called user ID, which just has one field, which is long or int or whatnot. And you don't want to, mix it with another int. So you want to give it. So you want to create a type to express this. And basically, these wrappers are one-element case classes, but you need to write. I don't know if you see this comment. This is boilerplate alert here. Basically, you need to write mappings for all these types over and over again. And as you can probably see here, they are very, very repetitive, almost to the point of being, you want to generate them, basically. There is no, human intervention needed here. Everything is very easy. You need to just use apply and just to create the value and use this one and only field to get it back. But you can't. So you might want to try to write a generic wrapper. This is the best we came up with, but you won't be able to do it. First of all, you need a cast. So it's not really a type-safe thing. Why do you need a cast? You need a cast because everything you get, there is no concept of case class on type system level. There's only a concept of product, and product just has fields of type any, which means that you don't know a type and you need to assert to a compiler here that you need a concrete type. The other thing is that you want to do it for basically one-element case classes, which is another concept you cannot really express because every case class inherits from product, which can have any number of fields, and there is basically no way to restrict it. So you can write code that will eliminate your boilerplate, but this code will be not really type safe and, not really correct, actually. And you probably won't be able to do better in pure Scala. You can use map2, which is a slick-only thing. Is anyone not familiar with map2? All right, that's bad, because it's a really stupid concept that I don't want to explain. So map2 is kind of a marker in Slick that you can extend from, and then it will know how to map itself into database, basically. But since you need to extend your domain level case class with a Slick-only concept, you are basically polluting your domain with database stuff. And you're coupling it in a very hard way, because you need to extend from something that Slick provides. So this is, while this is a solution, it's not really a good solution. The other thing is Shapeless, basically. And in Shapeless, there is this funny thing that's called generic. Put here. And generic is basically, in a nutshell, it's a way of mapping case classes to H lists. Or basically things to H lists, but case classes do naturally map themselves to H lists. And if you use Shapeless, you can write it in a type-safe way. It's a correct solution. I just don't want you to dwell over it, but it's type-safe. But first of all, you have a Shapeless as a dependency, and basically you have this dependency only for stating that one element tuples are isomorphic to its only element, which is an awful lot of code to state this very obvious fact. And the other thing is that, well, Shapeless involves some mindset, I would say, right, to have. And not everyone wants or needs Shapeless in their project. But yeah, it's a possible solution. But if you do not want to introduce Shapeless, even if you introduce Shapeless, you'll have one problem. Basically, you won't be able to map, for non-obvious reasons, you won't be able to map one element tables, one column tables. Okay, you won't be able to provide a mapping for this kind of table. You'll get an error which is very non-obvious. You'll get something that you need a type A, but you're giving a type B, which is very non-obvious why it happens, and it only becomes obvious when you turn in logging implicits. When you log implicit resolutions, you'll get that basically there are two ways of. You just provided an ambiguous resolution. You provided something that's Slick called rep column shape by means of your catch-all implicit that you've just written in or using Shapeless, and the other is that you wrote when you wrote a table mapping. Kind of a non-obvious. You won't be able to get over this totally. So if you want a solution that is truly automatic and well, flawless in every aspect, you will have to somehow disable automatic derivation if some other derivations exists. Now, if you see a sentence like this, then you probably cry because it's impossible in pure Scala. You cannot affect implicit resolution in a way like this. But you're going to need this. So why is it a problem? Well, first of all, as I said, you need case classes will need to be extended by their respective products. So if I have a 2-field case class, I want it to be a product 2. And in general, n-field case class should be a product of n, not just a generic product, which is not a thing in Scala. And because of this, you are not able to not only restrict access to fields, but you don't know how many fields you have. So you can say that you want a mapping for one element case classes, Also, you need a construct function for a case class, but construct function is a companion. In case class companion, basically it's an apply method, which you don't have access to. And basically, I can't understand why Scala compiler can't provide it for you. Any thoughts? Why, I know, 3-element case class of int string long isn't a product 3 of respectively int string long, and why there is no, if you are familiar with current shape of collections library in Scala, then every collection has a generic companion method or something like this, through which it can access its companion. So compiler, while it generates all these applies and so on, should really be generating it for us, but it doesn't. And that's the problem. And I perceive it as a Scala's fault, basically. Because, or maybe someone sees a reason why it's not like this. So it's Scala's fault. And we need to somehow get around it, or get over it. And that's why we created a Kebs, basically. So if there is no way to write it in pure Scala, then not everything is lost, because there is one escape hatch. That's a nice word, escape hatch, that lets programmers write code that's not really possible in Scala as a language. And this is, well, what you probably expected and heard of, it's macros. And the only way, map2, which we talked about, and generic from Shapeless, are obviously written using macros, because there is no way to do it in Scala. So if we wanted to do the same thing as a Shapeless generic, plus the ability to turn off and on implicit generation when we need it, then our only way to do it will be macros. And I don't know how familiar are you with macros as a concept, but there are two flavors of macros. I'm not sure how long the state will be, but because Scala macros are being changed as we speak in preparation of .t. But for now, we have two flavors or two types of macros. There are whitebox macros and blackbox macros. And despite funny names, there are some obvious differences. So one is that whitebox macros can basically say that I'm bailing out. I'm not generating anything right now. Even if I'm invoke to provide something like implicit, even if I'm being enrolled, I can bail out and say, OK, I cannot do it. And it's not a compilation error. So this ability makes it useful to us, because we can disable automatic derivation based on context, which we needed, because if we map one element, one column tables, then we have two derivations, and we want to derive our catch-all implicit, which will solve all our problems. And it looks like this. Actually, what we're doing here is we're providing an implicit, and these implicits generate what's a Slicks isomorphism. And Slicks isomorphism is a concept of isomorphism, one-to-one mapping from what you know from mathematics, basically. The only thing that's probably, I don't know, unusual here is that this implementation is a macro implementation. It calls our own macros, which materialize value columns, which is our macro which does all this logic. So basically, the only interesting thing here is that we are able to, as this comment states, and the implementation is in fact, I would say, correct, is that we are able to see at what point we are being enrolled, and either create the implicit we're asked to create, or actually do not create it and say, and abort the computation, but given that we are a Whitebox macro, we do not really have to, I mean, it's not really a compilation error, okay? So we can say we are not providing any implicit right now because, I don't know, something, there is an enclosing mapped projection, but still is not a compilation error. And other implicits will be tried, respectively, till at least one, or actually at most one is found, okay? So this gives us this nice ability to turn on or off based on actually context that we are being called on. Our job, basically, or our computation, which is something you won't be able to get when you use Shapeless. Even though Shapeless is more generic than we are, basically, but it's not, I would say it's not tailored to, to a specific use case, right? To a specific use case that emerges from using Slick, actually, and you know, it is only really valid in this context, okay? And so maybe that's the answer to the question why we are actually writing this. Because any other library will be more generic, will try to be more generic, and won't be tailored to very specific use cases that we, being tailored to very specific libraries, can, you know, optimize for, so to say, okay? So the showcase is that when you have a lot of these, and given this implementation, you have just seen, you're able to go to this. Okay, for a better effect, huh? So everything that can be seen here, that you see here, can be automatically generated, right? It's a no-brainer. There is no intelligence, I would say, involved, right? So just throw it away, import Kebs, and it will generate it for you. And we have more goodies, like we support SlickPG, which is a very popular driver because, you know, people use Postgres a lot. We support Enumeratum, which is very popular library, and so on, so on. If you are not that fond of imports, then we provide a tray that you can actually import to kind of you know, lessen the scope of impact, and so we're supporting one-column tables, which you won't get using anything else. It doesn't seem really important, but that was actually a case that we found on production. All right, the next source of boilerplate, which is the biggest source of boilerplate I actually seen in my life, is spray.json. So my personal rant is, I'm not really sure why people use spray.json. This library is awful, but it's goddamn awful, and there are better libraries. Whatever you, I don't know, like or want, be it play.json or Circa or whatnot, everything is better than spray.json. Spray.json is the biggest source of boilerplate I've ever seen in my life. Just small things. First of all, you need to, if you want a flat format in which there is a one-element case class which you are mapping to JSON, and you don't want a kind of a field name value mapping, you just want a value, then you can do it because Scala, right? That's exactly the same case as with Slick. Now, but despite this, first of all, you need to count the number of fields in your case classes for it to generate a format. So you need to know if you want to call JSON format 2 or JSON format 3 or JSON format 6. If you change it, I don't know, you add a field to a case class, then you need to change a JSON format 6 from JSON format 6 to JSON format 7 and back. So I'm not sure why people from Spray did not provide, I don't know, a macro to generate this. Like guys from play.json did, or Circa did, but, well, they are not providing this, so you're on your own, basically. And you need to mindlessly count the number of these fields and so on, and change them back and forth, depending on changes to your model. The other thing is, which might not be visible here, is that In Spray, there are concepts of root JSON format, which is like a, I don't know, JSON object or something like this, and JSON format, which is I don't know, unspecified JSON format, which might be a single value or object. Now, this is all good, but since root JSON format is a child of JSON format, then you are not able to provide the same implicits or two implicits for root JSON format and JSON format in the same scope because they are ambiguous. So you are not able to decide whether you want a root or not JSON format automatically in any way. So the solutions to this problem are either you switch to something else. I just happen to put a play JSON here, but just you know, switch to whatever you want. Or you can do it using Shapeless. Well, you won't be able to mix flat and non-flat formats because Shapeless is no magic. And the code that you will need to write will get a bit hairy. And because you need to somehow get the name of the fields from case class and so on. Someone did this. There is a link here. I will send a link to my presentation. You can go there. It's a good code, but still it's a hairy code. And still it doesn't solve all your problems. Now, we want to automatically generate, be it a root JSON format or flat JSON format for one-element case classes, and switch between them depending on context. So if you want really a JSON object, we generate a root JSON format for you, and if you do not, then we can generate a generic JSON format for you. And this automatic switch is something you won't be able to do in any other way. So, and yes, going back to my observation that Whitebox macros can decide whether or not they complete their unrolling, we can easily break the language rules, or the Scala language rules, and provide two implicits that basically return the same thing. Well, with some respect of subtyping, but well, root JSON format is a JSON format. And we are able to escape the dreaded ambiguous implicit resolution. You want to see the implementation? Let's do it like this. It's 7 minutes to 9. And I'm always being accused of speaking for too long, so this time I'm going to make it shorter. So how much time do I have?
Like 7 minutes.
7 minutes. You don't want to see this implementation, but well, macros, right? So showcase. Yes, showcases are the most important things. So this is the boilerplate, and once again. All right. Well, sorry, I think it's impressive, but now I'm even more sorry because I forced you to clap your hands. The Scala's faults are the same when it comes to writing a flat or non-flat formats, because it all boils down to not being able to provide well, generic access to case class on Scala level, on Scala language level. But there is one more Scala's fault I think is very important. It's that the Scala's implicit prioritization is well, stupid comes to mind, but maybe that's a real word. Is not really good working thing. Okay. So implicit prioritization in its current shape in Scala is kind of a one-way street. So you can just go from maybe I'll just show you an example. So this works. Okay. So you can prioritize by subclassing. So implicits that are resolved from subclass, they do have lower priority than implicits that are resolved from superclass. Yes. So this works because even though two implicits do provide the same type, this one is chosen because it's defined in proper subclass. Okay. But it's, as I said, one-way street. If you change types and you want something less specific to have higher priority, then it doesn't compile. So you can only, it's like, you know, the first fourth Scala. you can have any color you want as long as it's black. So in Scala, you can have implicit prioritization as long as you prefer more specific things first, like here. Okay? Then it works. In other cases, it doesn't. So it's not really implicit prioritization. It's just a way of grouping things. So I think everyone would be more happy if proper, I would say, implicit prioritization were provided in Scala. Now, given that the trends are that, as I heard, that implicits are going through some changes, and maybe they will be less powerful, is that the right word? Then probably it will never happen. I mean, going back to sanity here, this will always be wrong. And we have tons of other features. Some of them are really impressive. Like my colleague there, Damian Brunecki, he added support for case classes which have more than 22 fields. Which is something that lifts another Scala restriction. There is a PR. Oh yeah, I'm going to show you how easy it is to to PR to Kebs. So you just go to GitHub, and then you don't need to, I don't know, I would say you don't need to know much about writing macros and so on. We have foundations already provided. Even something that seems very hard can be done in like this 22 field limit restriction can be done in like 10 lines or something, because this is the logic here. Here. Lo and behold. Do you have any sources of boilerplate you want to talk about, or you have on your mind? Well, if you do in the future, then just please PR us, okay? I could go on talking about bad stuff in macros, because, well, Scala isn't free from errors, but macros aren't free from errors and, well, blunt mistakes either. Well, that's the worst API ever. Badly designed, badly documented. It's something that only moron would have created, I would say, but it's basically, it's something like that reminds me of managing memory in C, or in C days. So you can shoot yourself on the foot very easily. And correct semantics are really not enforced in any way. So you can write a code that macro unrolls and it type checks, but it will throw some cryptic error which you won't be able to debug, because debugging is hard as hell. So basically, we'll really need to have a better solution to write macros, basically. Well, homo-iconic languages are something that we would really, want, like in Clojure, right, or Lisp. These languages are homo-iconic, so the representation of code and data is really the same. So writing macros is just the same kind of programming as writing anything else in this language. In Scala, it will never happen, but at least cleaner API would be, I would say, needed. And which one is important here? Both are. Macro programming is very fragile. So because of all these stupid things in API, and basically the thing that it's not documented, and the knowledge is scattered throughout all the internet, and you are not really able to have any one definite source of knowledge, it's very fragile. So you will break your code bases, and you need to test it and test it and test it, and more code bases to be, at least robust, okay? Which is what we are doing. The other thing is that Scala compiler isn't really known for its speed, right? And it's even more slow. It's even slower when the macros are being unrolled, especially Whitebox macros, because their nature is that they are unrolled in every possible point. So compilation times really do suffer. Empirical evidence is that we observed about 10% growth on 40 DTOs being processed by Kebs, which is not really much, but still, it will be a linear growth. And yeah, let's go to good stuff. Okay, let's be honest here. Whitebox, or if every macro is like pasting the code over and over and over, right, in a programmatic way. So basically, Whitebox macros and any other macro actually will just take a code. Say you emit an implicit, and you will generate a tree that describes this implicits, and you will copy this code over and over and over everywhere where this implicit is needed. Which means that, first of all, the size of the compiled program will grow dramatically. In Scala 2.12, it won't be that hard because Scala 2.12 will compile, say, closures in using the lambda-phi allocation scheme. So it will use invoke dynamic instruction instead of emitting anonymous case classes in bytecode ad nauseam. So it will be a bit better, but still the size of the compiled program you can expect to grow. Because what you basically did is pasting code over and over and over. The runtime effect is that it can cause more allocations because you will allocate things over and over and over. You're not, say, if you write it by hand, you will do something like implicit val equals to blah, blah, blah. Then you will have it basically effectively cached, right? Well, while using macros, you won't have it cached. You will just kind of copy this expression to every way where it's used. So probably more things will be allocated. But we actually do have benchmarks, and they, because they are very short-lived objects, more often than not, they do not cause any measurable effect on performance of the program. But still, you can go to benchmarks folder on GitHub and check for yourself. I mean, thanks to a good garbage collector and a good, generational properties of this code, probably we're not. That's probably why we're not observing any meaningful impact. All right, the last one is not really not good stuff. So first, you do not have to write it, which is a profound good stuff. There are some use cases like conversion to snake case, right? You want a snakified JSON format, then, well, if you are not using macros, you will use something like runtime reflection to get the fields of case classes and turn them into snake case and emit them to JSON, which will be slow. Now, if you use macros, you can do it. You can skip the runtime reflection. You can do it in compile time and just emit string constants, for example. So you are not paying for conversion to snake case on every code and decode of JSON object. And the last one is that you can do amazing things that bend language rules, like smart JSON formats, which, depending on context, are either flat, non-flat, or whatnot. Thanks. Thank you very much. There is a postscriptum, which is that we happen to be, I don't know if it's the right thing to say, we are part of Scala's pre-initiative. I mean, the project is, not we as people. So if you want to hack it, then the first or the next or subsequent, I should say, meeting of this organization, I think it can be called an organization, will be at, and we'll be there, and we'll prepare some things to if you want to hack Kebs, then you will have a repo and our guidance. Well, here basically, it's before a Scala Wave conference. Okay, so you're happy. I mean, we'll be happy if you join us, if you will. Thank you.